All right, let's look at the homework 5.2, 5.3, problem number 15. All right, so let's look at this problem. All right, so we want to maximize the amount of nitrogen for part A, and we want to minimize for part B. So what we want to do is maximize and also minimize the nitrogen. So I'm going to call it N is equal to, all right, I'm going to use X for brand A, so X bags of brand A, and we're going to use Y bags of brand B. So it's going to be 5X plus 4Y. It's going to be a total amount of nitrogen. All right, and subject to, we have some requirement. So subject to. All right, so it says that, let's see, indicate the group needs at least 2,800 pounds of phosphoric acid. So it's going to be phosphoric acid is 7X plus 7Y. And this has to be greater than or equal to 2,800. All right, so we got that. And the other requirement is chloride is at most 600 pounds. All right, so chloride, so amount of chloride is 2X plus Y. And this has to be at most 600 pounds. So it's going to be less than or equal to 600. Right? Then just to be realistic, we can add the non-negative constraint. X and Y has to be greater than or equal to 0. Right? So let's sketch the feasible region. Right? So we're going to draw y-axis here, and here is the x-axis there. All right, so let's look at the first inequality. So boundary line, so x-intercept, so hide 7y, so 7x is equal to 2,800. So x is equal to 28 divided by 7 is 4, and so 400. So x intercept is 400. So I'm going to just put 400 maybe around here. Let's see, let's put 400 here. All right, and also y-intercept is of course 400 too here. So maybe I'll put the 400 right here. All right. Then we have to go through those 2 points. So the boundary line is going to look somewhat like that, right? So that's the first one. All right, second one, x-intercept is going to be 2x equals 600, so 300, right? So 300 is going to be right here before 400, so say 300 is right there. All right, then y-intercept is 600 there, so it's going to go, let's see, probably somewhere around here. All right, 600. All right, then we just have to connect those two guys together. So we have something like that, right? So that's the second borderline. All right, and of course you have a non-negative constraint, so it's going to stay in the first quadrant. All right, so which region? Let's see. Look at the first inequality, and you can see that I'll try 0, 0. 0, 0 does not satisfy the inequality, which means that we have to shade, I'm going to put the arrow, we have to shade this side, which is the side doesn't contain 0, 0. But second inequality, 0, 0 does satisfy, so you have to shade the bottom side, right? And you can see that here. So it has to be above this borderline and below that borderline, and to the right of the y-axis because of the non-negative constraint. So we're talking about this triangular region. Right, this is the feasible region. All right. And then what we want to do is we want to maximize and minimize this n function. All right. So first I'm going to rewrite it. So I'm take this objective function, and maybe I'll put it over here. All right. First, I'm going to subtract 5x from both sides. So we get the negative 5x plus n is equal to 4y. All right, then I'm going to divide through by 4. So you have a negative 5 over 4x plus n over 4, and this is equal to y. All right, so you can see that the slope is right here, negative 5/4. All right, so number 1 has a slope of negative 1, so it's going to be steeper than the borderline number 1. But let's see, number 2 has a borderline, so you go to 300, you go down 600, which means that the slope is negative 2. So it's not quite as steep, right? So you can see that if you push that line, so it's got to be steeper than this guy, and then not as steep as that guy. So as you push the line up, objective function line up, and I think it's gonna be, let's see, it's gonna be kind of like this. So I'm gonna draw with the red line maybe. So red line. So the last point it's gonna hit is this guy right here. So here is the objective function line. All right. So I made sure that it's not as steep as the number 2 line, but it's steeper than the number 1 line. So it's going to look like that. So it looks like a maximum is going to occur at this point, right? So which is x is equal to 0 and y equals 600, right? So let's type it in first. Actually, we have to get the value. Right, so at that point, n is going to be equal to, right, 5 times x is 0, so that's 0. 4 times 600, so it's going to be 2400. Right, so let's type it in. So add the 0 bags of brand A, and let's see, what was the number? Let's see here, 600. All right, sorry about that. So 600 bags, and then yep, so that's that, and amount is 2,400 pounds. So check that. All right, we got that. All right, then what we want to do next is we want to minimize it. So we want to keep the slope of this objective function line, but we're gonna push it down as far as we can. Right, then see if which point we're gonna have the minimum. Right, so if you push it down, and then you will see that this is gonna hit something like this. Right, so it's the line is gonna look kind of like this. Right, making sure that these are parallel. Right. So minimum is going to occur at this point right here. All right, so this is going to be a minimum. And in this case, x is 0 and y is actually 400. So n is going to be, so at that point, Right, 5 times 0 plus 4 times 400, which is going to be 1600. Right, so let's type it in. All right, it's still 0 bags here, and we're gonna put the 400 bags of brand B. Then check that. All right, then amount of nitrogen is 14. Let's see, was it 1600? Sorry, 1600. Check the answer. Got that. All right, I guess that's it. I hope that this was clear.